Welcome to the online lectures for software engineering. In today's class, we'll be studying the design model. Now, this design model, it can be viewed in two different dimensions. Now, those two dimensions are process dimensions and abstraction dimensions. Now, what is this process dimension and abstraction dimension? Now, this process dimension, this indicates the evolution of design model. Now, what do you mean by the evolution of design model? Evolution means how the design is being formed that you're going to identify. Now, how is this design going to be identified? As tasks are executed, you get to know how the design model is going to be formed. So that is your process dimension. Then the next one is the abstraction dimension. Now, what is abstraction dimension? Abstraction dimension, it is going to represent each element of analysis model. Now, with the elements of analysis model, these are gathered within the requirement engineering phase. So it is going to take all the elements of your analysis model and it is going to transform it. Then it is going to transform it into a design. This process can also be called as refinement. Now, what happens in refinement? We have seen within the design concept, you're going to refine each and every element of the analysis model until it reaches the programming level statement. So that is going to happen within the abstraction dimension. Now, this design model, it is going to have four major elements: the data design element, the architectural design element, the component design element, and the interface design element. Let's see what this is in detail. Now, the first one is the data design element. Now, this data design element, it is going to create the models of data. Now, this is the data that you're going to use within the software and the different objects. It creates a model of data and objects that is represented at high level of abstraction. Now, what does high level of abstraction means? High level of abstraction means where you're defining the solution to the problem in broad terms. That is, you're not giving a lot of detail to explain the solution. Now, within this data and design element, you have the component level, application level, and business level. Now, what are these three different levels? Now, this component level, the component level is going to show you the design of the different data structures. As we are modeling the data, we are creating a model of data. That is why we are identifying what are the different data structures. Now, identifying here, it means we are identifying the design of that data structures. In addition to it, you're also going to identify if any algorithms that you're using within the software, you're also going to identify the algorithms that are manipulating the data. Now, this is identified, or this is essential for the creation of a high quality application. When you're creating a high quality application, you're going to do these two things. Then the next one is application level. Now, what happens at the application level? At the application level, the translation, what you're going to do is you're going to translate the data model into the database. Now, data model is what is the type of data that you're using. It is going to be translated into the database. Now, this conversion of this translation of data model into database, this is very important to achieve the objectives of business. This is essential so that you can achieve the objectives of business. Then next, coming to the business level. Now, what happens at the business level? Now, as within the previous level, we have taken all the data models and transformed it into database. Within the business level, you're going to identify all the different information storages that you're going to find all the different databases. And all these databases, these are reorganized into a data warehouse. Now, what is a data warehouse? Data warehouse, it is a huge collection of database. That is a combination of different databases. So, You're going to take different databases, reorganize them into different data warehouses. Now, when you have a data warehouse, you can have different data mining or knowledge discovery can be done within the data warehouse. Now, what is data mining? Data mining, it is like cleaning of data. You're extracting some relevant information from the database, that is called as data mining. Then knowledge discovery is if you suppose searching something within the data, you're discovering that details. And this all things that is working with the data warehouse, this entire thing, this has a great impact on the success of business. The next is the architectural design element. Now, within this architectural design element, the architectural design model, it is derived from three different sources. Now, what are the three sources? Information about the application domain for the software to be built. Now, information, whenever you're designing the architecture, it is necessary that you have information. It is necessary you have the information that needs to be used for making the architecture. If you do not have information, it will be difficult for you to make the architecture. The next is the specific requirement model. Now, what is requirement model? Requirement model is your analysis model. So you're going to take the specific analysis model. Now, what are those analysis model? It can be data flow diagrams. Now, what comes within the data flow diagrams? You can have your activity diagram, sequence diagrams. These are your data flow diagrams or analysis classes, and the relationships and collaboration. What is collaboration? Collaboration means communication. That is when you have all these things, when you know what are the different data flow diagrams, what are the analysis classes, how they are connected, those are the relationships. You've got two different classes, how are these two classes are connected. This thing is called as your relationship. And how these classes are going to communicate, if you know this, it becomes easy for you to create the architecture design element. Then the next one is the availability of architectural styles and patterns. That is whenever you're making the architectural design elements, you need to follow some specific styles and patterns, some recognized styles and patterns. So those styles and patterns need to be available. So this is the architectural design element. Now going next to the interface design element. Now what is interface? Interface is a point of interaction. Now within this interface design elements, you're going to study three different design elements. The three important elements of interface design are the user interface, external interfaces, and internal interfaces. Now within the within the user interface, that is the UI, the interface design, it is going to focus upon the aesthetic elements. Now, what are the aesthetic elements? Aesthetic elements means what is the layout, what is the color that you're using, or any graphics. That are the aesthetic elements within the user interface. This is the first one. Then the second one is ergonomic elements. Now within this ergonomic elements, here we have seen the layout. What is the layout of the entire software? Whereas within this ergonomic elements, you're going to identify what is the information layout, how the information is spread across the entire application, how you're going to access that information, and the placement and any user interface navigations that is going to be identified in here. Then the third one is technical elements. Now within this technical elements, you're going to identify what is the user interface pattern that you're following. Now, as you've got different architectural styles and patterns, you're also going to have user interface patterns. And you're also going to identify if there is any reusable components. So these are the three things that are covered within the user interface: the aesthetic elements, the ergonomic elements, and your technical elements. Then the second one is external interfaces. Now, what are external interface? External interface to other systems. That is how you're connecting. That is, it can be other devices, it can be networks, or the producers or consumers of information. Those are your external interface. That is external to the software that you've built. Now, within this external interface, this design the designing of the external interface, it requires the information about entities. It requires external interface. It requires the information of entity to which the information is received or sent. So that requires information of these two things. Whether you're receiving the information or you're sending the information, it needs the information of that particular thing. Now, this information, it is collected at the requirement engineering phase. As within this user interface, within the previous slide, here we have seen the specific requirements, they were collected. The analysis classes information, this is collected at the requirement engineering phase. This same way within here also, the external interface information, it is going to be collected at the requirement engineering phase, and this information will be verified when the interface design element is going to begin, or when it is going to start. That at that time you're going to verify it. First, you're going to identify it requirement engineering phase. Second, you're going to verify it when the interface design element is going to start. Now, within this external interfaces, there are a few activities, that is error checking and security features. These are the two activities that is going to happen within the external interface. Then the third one is internal interfaces between various design elements. Now, internal interfaces mean that are present within the application. Those are your internal interfaces. Now, within this internal interfaces, it is these the design of internal interfaces, it is closely aligned with component level design. The next design that we're going to study is component level design. So this works similar with the component level design. Now there is an interface representation for control panel. Now within this interface representation of control panel, here we have got one class, that is your control panel. Within the control panel, within the class, there are three things. You're going to have the name, then you're going to have the attributes, and then you're going to have the operation, the three compartments within the class diagram. Now this is the representation of interface. This symbol, the circle, represents interface. Now this interface, the control panel, this example, again, we are taking the safe home security example. Within this entire software engineering, we are taking the same example of safe home security system. But from that, we are taking only the control panel. Now within this control panel, you can have access to the safe home security system via your mobile phone or through the wireless PDA, a personal device assistant. You can have a separate device. So these two are connected via the keypad. And the next one, this is your control panel. Now this you're going to have another class, that is your keypad class, that it is going to do two operations: read key stores and decode the keys. This is your realization relationship, that is this dotted line with a hollow circle. This is called as realization, and this is your dependency relationship. Now realization relationship means this control panel, it is going to have these operations. Now these operations, these cannot be executed until the keystroke is being read. That is, you can say control panel, this executes the other part. So you need to read each and every keystroke, and you also need to decode each and every key. So there's the interface representation for control panel. This is your interface representation. There's a dependency relationship and the realization relationship. The next is the component level design. Now this component level design, it is similar to your internal interface. Now within this internal interface, the one of the UML diagram, it is also called as the component level, sorry, the component diagram. So this symbol is your component diagram. Now what is the component symbol? That is, you're going to have a rectangle with two protruding rectangles on top of it. So this is your component symbol. So this you have got the sensor management as a component. This have got a dependency relationship to the sensor. Now the component level describes the internal details of each software component. Now this component level diagrams, these are used so that you get to know that it is going to describe the organization and wiring of each and every physical component. Like it is going to tell you the structure, how they need to be placed. That is the task of the component level diagram. Now this internal details, how it is going to do this task, it is going to accomplish this by making use of the component level design. Now within this component level design, it is going to identify all the different data structures. Now these data structures are going to be identified for all local data objects, and if there are any algorithms that are also going to be identified, or if there are any details of processing, how you're going to process the data, that is going to be identified. The detail of processing that occurs within a component. And also the interfaces. Now these interfaces are the ones that is going to allow access to all operations, or we can say all different behaviors, all component operations, or this can also be told as behaviors. So this is your component level design. It is going to tell you the internal detail of the software component. That is how they are organized, what is the connections, and how it is going to do that. This task, it is accomplished by identifying all the different data structures of local objects, any algorithms, details of processing within a component, plus any interfaces that is going to show you how all of this interactions are going to take place. So that is your component level design element. The next one is your deployment level design element. You also have a diagram called as deployment diagram. Now this deployment diagram, this is called as your node. This cube structure, this is called node. There are different. Now this deployment diagram, this is going to tell you how, like it is going to map all the software pieces of the system into the hardware. Deployment level diagram, it maps the software of a system to the hardware that are going to execute it. So the component level diagram is going to tell you how all the software elements are arranged, what are the connections, and the deployment level diagram is going to tell you what is the hardware, where is the software going to reside. It is going to map all the software to the hardware that is going to execute it. So this deployment level diagram, it indicates how the software functionalities and subsystems will be allocated within the physical computing environment that will support the software. It is basically going to tell you where each and every piece is going to be integrated, where it is going to be deployed. Deployment is the delivery of the software. So within this software, how the software is going to be embedded within the hardware, that is going to be identified. So here we have got three nodes: the control panel, the CPI server, and the personal computer. Now within the personal computer, you're going to have external access package. Now this symbol, this is for package. So you're going to have external access, surveillance, security, home management, communication. This is again the example of safe home security system. You're not taking different examples so that it is not confusing. So for this personal computer, you've got different packages. Now this external access, this can be taken by the control panel, that is accessed by the control panel, and this control panel again has a package that is security. Then you've got CPI server that has got homeowner access. Now within this deployment diagrams, another thing that you can use that is called as artifacts. What are artifacts? Artifacts are documents. Any document file, if it is needed, if you're using that, if that needs to be deployed within the software, then that can also be added within the deployment diagram. So this is the end of the design model.